Being that this is a lighting class, we're going to talk this week about where light comes from, or the different sources of light. There are natural sources of light, the most obvious being the sun, but other things like fire or flames, like a candle flame if you're at a candlelit dinner, and then chemical reactions such as lightning bugs or the lightning of a lightning storm. In the early days of cinematography, we used incandescent light bulbs, and we still do. This is very much what Edison created many years ago as the first light bulb. It's a very simple technology. It's a wire across two electrodes, and when electricity is applied, the filament has a resistance to the electricity, and it starts to heat up, and that heat energy turns into light energy. Some of you might be wondering why this filament that's heating up and glowing doesn't just turn into a flame. That would be a very good question. And the reason for the not turning into a flame is because there is no oxygen in the bulb. In fact, there's no atmosphere whatsoever. The light bulb has a vacuum or no atmosphere whatsoever, and that's the reason it's a sphere, because a sphere is a very strong structure. Light from a bulb that has a tungsten wire, while very cheap to make, are very inefficient bulbs. One is they produce very little light for the amount of watts or energy it takes to produce them. And two, they only last for tens of hours because the filament, the carbon on the filament, burns away and they eventually break. Larger bulbs, like a 10,000 watt bulb that you see on the right, is basically the exact same design but made much, much bigger. The problem with those bulbs in the old days is that the carbon would burn off and it would create a black haze on the glass. In the old days, the electricians would have to take the bulbs out of the light sources, and there was sand in the bulb, and they'd have to swirl the sand around on the bulb to get rid of the black carbon. A new technology came on the scene, a quartz halogen bulb. It's still using the tungsten wire to produce the light from the resistance from electricity. But the advantages of the quartz halogen is there's a halogen gas inside the bulb, and the halogen gas connects to the carbon that's burning off, and it actually replaces it back onto the filament. The magic of science. The quartz refers to the glass. It's a quartz glass. The advantage of quartz is it can take a much higher level of heat, therefore it can be much closer to the filament. And also you'll notice it's not a spherical shape. That's because there's not a vacuum in the bulb anymore, but a halogen gas. When you change a quartz halogen bulb in a fixture, well, there's certain safety precautions. One, make sure the light's unplugged. The other thing you want to make sure is that you don't put your fingers on the quartz glass itself, because when that light turns on, the oil in your fingers will change the temperature on the quartz glass, therefore causing it to crack. Because of the halogen gas, these bulbs last much longer. They now last hundreds of hours compared to the regular incandescent bulb. But as you can see, the cost is now much higher to make and buy. In the early days of filmmaking, the ASA, or speed of the film, was quite slow. And when you're shooting outside, you need very bright lights to compare to the sun. And of course, it needs to be a bluer light source. Looking at the spaghetti westerns, you can see under their hats, they needed to fill in the shadows caused by the sun. So they needed a very powerful light source. The technology that solved this problem were arc lights. Arc is created by two rods coming together, and it creates a dead short. and there is an arc flame that jumps across. You can see this when you go past buildings that are being constructed and they're welding pieces of metal together, and you see the big bright blue flashes of light coming off the arc welders. This is very similar technology. Arc lights are very big, very heavy. They run on DC voltage and they require a lot of power, but they're very efficient and very bright. There are two rods in the housing, one negative, one positive. As the rods create the arc light, the carbon from the rods burn away, so there's a mechanism that feeds the rods together. It's the electrician's job to make sure that there's a proper gap between the two rods. The rods last for about a half an hour, and then they need to be replaced.
We're going to do something different. We're going to show you what that looks like with the door open. You should never do this, never ever, but we're going to do it today. So I'm going to turn the switch on, and we're going to go ahead and strike this guy right now. Beautiful strike. I hope you got that. I can't look at it, but it sounds real good. So that's how it burns inside there. That's the flame. Pretty neat, pretty neat. So I'm going to go ahead and I'm going to close this door. Now it's safe to look at it, and I'll look at it and see what I did inside. Let me step out in front now and show you what kind of light it puts out. You can take all your HMIs and throw them away. This is the only light. Pinpoint source, beautiful skin tones, crisp, beautiful light. And we got a little smoke, a little atmosphere going with it too, right?
The next development in lighting technology is the HMI. The HMI light is an enclosed arc. It's enclosed in that quartz bulb with halogen gas to be able to reattach the carbon particles. As you can see, there is no filament. An arc is created between the two electrodes inside this closed glass quartz enclosure. The quartz glass can take the high heat. The halogen gas reattaches the burned off carbon. The HMI light lasts for hundreds of hours. It's a very efficient light and produces a lot of light for the amount of power it consumes. Although, as you can see by the price, they are quite expensive. Arc lighting technology is even used in projectors for large movie theaters. Another type of arc technology is called a xenon light. These use AC current. Xenon lights are the moving lights that shine into the night sky to herald the opening of a new store. In our industry, they're used for pinpoint lighting sources for strong lighting coming through a window. The next source of lights are fluorescents. Fluorescents were primarily used in industry for lighting large buildings and corporate offices. They produce a very soft, continuous light source at very low wattage or power consumption. The downside with fluorescents is the light spectrum is quite bad for skin color and very hard to use for filmmaking, as it has a large green spike in the color spectrum. Although as it started being used for film industry, KinoFlow created fluorescent light bulbs that had a more continuous and nicer spectrum of light. Fluorescents use very little power, and they last for thousands of hours, and they even created bulbs that would be used in household lamps. Fluorescent lights use a mixture of electricity and chemistry. As electrons come from the cathodes at the end of the bulb, the ultraviolet radiation from the electrical source mixes with the phosphor coating to start creating a light source. The newest lighting technology to enter our industry is the LED light. The LED light was very expensive when it first came into the market, but the price is going rapidly down. And LED lights are even being used in house and businesses. They're a very efficient light source, they're cool light, and they last thousands of hours. They can be made into soft sources or hard sources. And they can be color mixed to create any color under the rainbow. The LED technology can be used in a wide array of different styles of lights. Soft or hard, even tape light that can be mounted to the visor of a car for a night shot. They can be created in any color temperature, and there are even RGB, red, green, blue, for creating mixtures of colors used quite often in theater and music venues. Electricity is expensive, so finding a light source that has a high output of lumens to the amount of wattage is what we're looking for. Incandescent lights, while being less expensive, create a lot of heat and use a lot of energy for the amount of lumens. So you can see in this chart, for the brightness range of 800 lumens, for an incandescent light, you would need 60 watts. For a halogen light source, you would need 42 watts. For a fluorescent light source, 12 watts, and an LED light source, 10 watts. So that concludes our walk through lighting and the type of lights we use in our industry.